Okay, for this last video, what I want to do is introduce you to the within subjects, or what's sometimes referred to as the repeated measures design. We're going to talk a little bit about what it is, why it's so great, and then I'm going to save until the next unit actually breaking down why mathematically it is so great. We'll talk about that more later. But first of all, what is it? So a within subjects design is one in which every participant, each subject, receives multiple treatments, and then each participant is measured after each treatment. So we'll use a different example for this one. We'll use a different example. We'll use Prozac versus electroconvulsive therapy, ECT, as treatments for depression. So what we want to know is which of these two makes depression go away faster or more fully, Prozac or ECT. So what we're going to do in our experiment is every participant receives Prozac and their depression is measured. And every participant receives ECT and then their depression is measured. So every person will have received both of these treatments by the end of the experiment. Okay, sounds simple enough. So you ask, why is it so awesome? And the answer is simple. In 3 words, power, power, power. Or, as we talked about on the first day, power, power, who's got the power? Power is the most critical element of this design because it virtually eliminates pre-existing differences between groups. Remember, one of the reasons why matched pairs designs was so helpful is because it minimized these differences. For every person in the treatment group, you had a similar other person in the control group. We matched people on IQs. For within subjects design, we virtually eliminated pre-existing differences because every participant in the Prozac group is also a participant in the ECT group. So what we'd expect is their pre-treatment scores on depression to be identical, or at least nearly identical, right? They both have the same genetic makeup because they're the same person. They both have the same childhood because they're the same person. They both have the same 4th grade experience because they're the same person. And so because of this, we can more easily detect the meaningful differences between our treatment groups. And by meaningful differences, what we mean here is the differences due to our manipulation. Okay, so let me ask you this question. If you were to answer this in your own words, why are within subjects designs more powerful than matched pairs designs? Pause the video, and again, don't worry about getting this right or wrong. If you had to explain this to your grandma tonight, she said, tell me about what you learned in class today. I've heard about within subjects designs, but I don't think they're all the rage. We did just fine with matched pairs designs when I was a kid. I don't understand why we need within subjects. Sorry. Anyway, your grandma asked you that question. In 2 to 3 sentences, what would you tell her? Why is a within subject design more powerful? Pause the video, jot your best answer. Don't worry if it's not right, and then we'll come back. Okay, why are these designs more powerful? Because they increase the pre-treatment similarity between groups. Whereas the matched pairs design, people in one group are similar to those in the other group on one variable. In a within subjects design, they are identical, or at least nearly identical, on all variables. Identical in gender, identical in IQ, identical in childhood experiences, identical in genetic factors, temperament, etc. Within subject design maximizes this pre-treatment similarity. Okay, so what should we consider? Why might we think about using this? Well, first of all, it increases our power tremendously. This is one of the most statistically powerful designs that's out there. Why not use it? Well, one of the potential downsides is that order effects can harm our internal validity. And in just a moment, we'll talk about what these order effects are. But it might be better to understand if you think about a particular kind of experiment. Okay, so I'm gonna give you an imaginary scenario. I'm going to ask you first to think about what could go wrong in this scenario. So using a driving simulator, you want to compare the differences between driving unimpaired, driving while talking on a cell phone, and driving while legally intoxicated. But you're also concerned about power, so you decide to use a within subjects design. So you have each of your participants drive in each condition: 1, unimpaired; 2, on a cell phone; and 3, legally intoxicated. And you measure their skills. In addition to potentially ethical things that could go wrong, what could go wrong in this study? In other words, why might your results be inaccurate? So I want you to pause the video and give your best possible response to this. Don't worry again if it's not right. Okay, what I want to do is tell you about a couple of types of order effects. And in just a minute, I want you to see I'm going to ask you which, if any, of these order effects might apply to this scenario. So order effects are effects that repeating a process over and over again may have on your measured variable. So in this case, we want to know how well they're driving, so their performance in the driving simulator. That is, so here, our DV is driving performance. Our independent variable is the type of impairment, cell phone, drinking or intoxication, and no impairment. So order effects are the effect that repeating this kind of study again and again can have on people. Okay, so the first one is called practice effects. Practice effects are when participants learn something from their first trial that becomes easier later on. So if you imagine, let's imagine taking an IQ test. So I take an IQ test and then I'm given some sort of magic IQ intoxication chemical, and then I take the IQ test again. Lo and behold, my score goes up. Well, why might that be? It might be because I've practiced taking this test once and I'm better at taking it the second time. So practice effects happen when you learn from the first trial how to do a task better. So I want to ask you this question. Think about, is there any way in which our previous experiment on the driving simulator could have practice effects? If so, what would those look like? How would they affect the scores? 2, fatigue effects. Fatigue effects happen when participants become tired or less enthusiastic over the course of a long and repetitive experiment. So in the case of in this experiment, is there any way in which fatigue may affect our results? 3rd, what's called treatment carryover effects. This is where an earlier treatment continues to impact later trials. So for instance, earlier we talked about Prozac and ECT on depression. Well, imagine what might happen if I give you Prozac and I give you enough to get you up to a clinical dose, and I measure your depression on a Saturday. Then, on a Monday, I give you ECT and I measure your depression score. Well, even if the ECT did nothing, it's likely that the Prozac is still working on your system. That Prozac may still be decreasing your depression. It hasn't worn off yet. In other words, the first treatment had carried over to the second. Treatment carryover is when there are effects of earlier treatment on later trials. So think about, in our driving experiment and impairment, is there any way in which one treatment could carry over to a later trial? And the last one is what's called sensitization. Sensitization happens when participants realize what the independent and or the dependent variables are. In other words, okay, I got your Prozac and you measured my depression. And then you gave me ECT and you measured my depression. Well, guess what? I'm going to start to guess that whatever you're doing you think is going to impact my depression levels. And the more times I go through this, the more I realize, oh, what you're doing in these intervening time is designed to change my depression. So I want to ask you this. Is there any ways in which our experiment, our driving performance experiment, may be subject to sensitization order effects? So pause the video and make a note of if any or all or some of these effects would affect the level of driving or the capacity to drive? And if so, how would you expect each of these effects to impact scores? And we'll talk about this in class. Okay, so if these order effects are such a big problem to within subjects designs, what do we do? Do we just abandon the within subjects design? No, we try to deal with it. How are we going to deal with these order effects? Well, what we want to do is we want to try to minimize first each individual threat. So for instance, for practice, instead of just giving them one IQ test 2 times, we might give them 2 different versions of an IQ test. That way, their practice on the first one won't affect their score on the second one as much. For fatigue, we might make each of the tests shorter. For carryover, we might want to delay the time between trial 1 and trial 2. For sensitization, what we want to do is we want to prevent participants from noticing that you're manipulating anything. Okay? So we might use similar levels in all the conditions. Or we might change the levels so gradually that they don't notice. Or we might reduce sensitization by using a placebo treatment. So there's ways that we can attack each one of these individual threats. Again, for practice effects, we might give them, another way to do for practice effects is we might want to give them extensive practice before the experiment begins. So let them take a dozen IQ tests. And that way, now they've gotten as much practice, they've ramped their score up as much as they could. So now when we do our trials, that practice between trial 1 and trial 2 isn't going to affect them as much because they've all already gotten their practice in. For fatigue, if we've made it more interesting or brief or undemanding, it's likely that they're not going to get as fatigued. And for sensitization, remember we talked about you can use similar levels in all conditions or change the levels gradually or use a placebo treatment. Now, another way to deal with order effects is to try to use as few levels as possible. In other words, if we only have 2 different conditions that we're comparing, there's less of a chance for practice to affect them, or less chance that they're going to get fatigued than there is if we have 4 different ways of impairing them, or 8 different ways of impairing them. And the other way is we might try to mix up the sequences to try to balance out the order effects. So for instance, one of the dangers in an experiment with order effects is, let's say we always give people the Prozac first and then measure their depression. We always give them the ECT second. Well, if we find out that their depression levels are way down in ECT, that may be because always the Prozac is carrying over into the ECT. So the way we fix this is, well, we give half of our participants ECT first, and we see if their depression levels are as low as the ones who got ECT second. So, to follow up on our earlier question, in this driving simulator, first of all, the question I asked just a minute ago, which order effects do you have to worry about and why? Second, to what degree would counterbalancing solve the problems caused by these order effects? And third, how would you try to prevent order effects from harming the validity of your study? So I want you to finish your writing down below by answering those last 2 questions. How much would counterbalancing solve the problems, or would it not? How would you try to prevent order effects from impacting the validity of the study? Okay, so as a summary, let's see, what we're going to do is, in fact, here, let me just briefly say how you would go about counterbalancing. So, as in all of the within subjects or repeated measures design, every subject is observed in at least 2 different conditions. But what we want to do is for each participant, one way to deal with these order effects is to randomly determine the sequence of treatments for each participant. So subject 1, you roll the dice and they get ECT first and Prozac second. Roll the dice again and participant number 2 gets ECT first and Prozac second. Roll the dice and that third participant maybe gets Prozac first and ECT second. Okay, but there's an even better way to do this, which is what's called the counterbalanced within subjects design. So this is the last thing I want to say. the counterbalance within subjects design. So I want to say just a little bit about how you do this, the procedure, and some of the advantages of counterbalancing. And I'll mention a couple of disadvantages, but give you, in the end, the conclusions about counterbalance within subjects design. So how do we go about doing this? First of all, what we want to do is devise a set of sequences. So it's pretty easy for our Prozac and ECT because we only really have two sequences. We have Prozac and then ECT, and we have ECT and then Prozac. There's only two different sequences. For our other one, or other experiment, we have a few different possibilities. We have the alcohol impairment, and then cell phone impairment, and then no impairment. What's another sequence we could do? Well, we could do alcohol impairment, then no impairment, then cell phone. We could do cell phone, then alcohol, then no impairment. We could do cell phone, then no impairment, then alcohol. And for the last two, we could do no impairment, alcohol, cell phone, and no impairment, cell phone, alcohol. These are 6 different ways that we could give people a sequence of conditions so that every condition appears in every condition the same number of times. So for instance, alcohol appears as many times in the first as it does in the second, as it does in the third. Each one of the conditions appears in each time sequence 2 times. And every condition precedes every other condition just as many times as it follows that condition. What do we mean by this? Well, here, alcohol precedes the control. Here, alcohol precedes the control. Here, alcohol precedes the control. Okay? Does it follow the control just as many times? Here, alcohol follows the control. Alcohol follows the control, and alcohol follows the control right here. So every condition appears in every position the same number of times, and every condition precedes every other condition just as many times as it follows that condition. So for example, in this first sequence here, we have one experiment, one condition, then the other, and then one condition, then the other. Last, what we need to do is now randomly assign participants to a sequence. So instead of in a between groups participant where you either assign someone to the alcohol group or the cell phone group or the no treatment condition, now what you're assigning people to is participant 1 may get this one, participant 3 may get this one, participant 2 may get that, number 4 may get this, number 6 may get this, number 5 may get that one. So each participant is randomly assigned to a sequence of conditions. Okay, so as a summary, why do this? Well, counterbalancing is really helpful. It takes a lot of work to do this, but it's really helpful because we can balance out some of the routine order effects that we see. Okay, it's also really nice because we can learn about the effect of the within subject variable of order. In other words, one of the things from our first experiment over here that we can learn is we can actually learn, does ECT work better when it comes after Prozac instead of coming before it, or vice versa? So we can actually learn something about when these treatments are more or less effective. Or for instance, does talking on your cell phone really decrease performance when you've already imbibed alcohol? Okay, and we can learn about the effect of the between subjects variable of sequence. So in other words, we can learn about each one of these sequences and which one affects performance the most. Okay, these are some great reasons to counterbalance. What are the downsides? Well, one of the downsides is it might require more participants, because now here I have to get at least 6 different participants to fill out each one of these counterbalance conditions. Okay, 6 different orders needs at least 6 participants. It may require more participants, and the analysis ends up being more sophisticated because here I'm also looking at differences between orders, not just differences between the conditions. Okay, so in conclusion, why use counterbalance within subjects design? Because it balances out the routine order effects, my apologies, and it provides information not only about the effective treatment, but also about the effective order, the trials, the position, and the sequence. Okay, so that's all that we'll say today. The next step is going to be in the next unit when we talk about within subjects ANOVA and why and how it is that these within subject design actually reduce error. And that's going to be the numerical magical moment. My hope is that your eyes will pop and your life will never be the same. But for right now, it's enough to know about what these designs are like.